With the Nova One blog, coming at you with another lesson. At this time, we're talking about what linear regression and losses in machine learning. Before we start with this lesson, though, I recommend you watch one of my previous videos or one of my previous posts. You can read that as well on my blog. Basically, what we do is we talk about what the basics are in machine learning, like features, labels. We even code up an example at the end, and we use TensorFlow to train one of our models. So it's a really cool lesson. Go ahead and check it out. I'll put the link in the description below. And without further ado, let's go ahead and start with our lesson. So let's say you're running an internet campaign, and for every ad you run, you get some type of sales, right? So for one ad, you're getting $1,000. For 3 ads, you're getting $800. For 5, you're getting $2,300, and so on, right? So we want to find a trend in this data because it's going to be very useful for making predictions about what our sales will be for X number of ads. So I went ahead and plotted out this data on the graph. So on the x-axis, we have our ads run, so you can clearly see that here. And then on the y-axis, we have our sales for each number of ads run. So I'm just going to hover over some of the points so you can kind of see the relationship here. You can clearly see that this is a linear relationship by just looking at where the lines are going. It's not completely linear. You know, there's some points that are off, right? They're out of order, but you can clearly see them going up like a line, right? If you were to draw a line through this, you can clearly see a relationship. So I'm going to go ahead and draw that line. So we'll go here and put a trend line. And so now we can clearly see a relationship. This is by the way, this is a trend line, or a line that best fits the data. And you can go ahead and actually come up with this line yourself, but that's a whole nother topic. It's called the least squares method, and that helps you basically figure out where this line should be. So let's go ahead and move on. Remember the equation for a line in algebra class? All those other useless equations your algebra teacher wanted you to learn? Well, this one is not so useless. We can actually use it in our machine learning model. We can actually, get some predictions for the next data point, right? For the next input. So remember, it's y equals mx plus b. And let's just quickly go over what exactly the variables mean in this equation if you forgot from your math class. So y is the sales we make for the number of ads we run, right? So it's basically the dependent variable. It depends on what we input into the function. It also depends on the slope and the y-intercept. So that's why it's a dependent variable. And m is the slope or rate of change, right? So it's increasing by a certain amount every time. And that's basically what m is. So m can be going up like this, or it could be going down. It's just basically the rate of change, right? And then x is the independent variable. It doesn't depend on anything. You put it in the function, it's still the same number. It's the number of ads we're running in this example. And then b is just the y-intercept. And the best way I can explain that is, where does the line touch on the y-axis, right, for this equation? So if the y-intercept was a bigger number, let's say 10,000, then the line would start all the way up here. If the y-intercept was 1,000, which is where it is, that's exactly where it would touch the y-axis. So that's basically the y-intercept. A similar equation in machine learning. I should say it's the same, but we're just using different variables which represent the same thing. So in machine learning, we're using y prime equals b plus w1 times x1. And in this equation, y prime is just the predicted value or label for a given input, right? It's the same thing as y in this equation. B is called the bias instead of the y-intercept, but it's the same thing as the y-intercept. W1 is called the weight of feature 1. It's the same thing as the slope of a line, so it's the same thing as m in this equation. And then x1 is the feature or a value that we're given, and we can just insert to the function. It's also the independent variable as well. And we're using w1, x1 because we can have multiple features with varying weights, right? So instead of this being y prime equals b plus w1 x1, we could have y prime equals b plus w1 times x1 plus w2 times x2 and so on. So we could have multiple features and weights in machine learning for this equation. But that is getting too complicated. I just want to keep it simple and just have one feature with one weight for now, just so you can understand the concepts. So that brings us on to our next topic here, which is loss in machine learning. And you can see the difference between what the model output, right? So for this point, for example, it was 3 and we got $800, if you remember. And the model is predicting about a value of around $900 or $850. And the difference between these 2 points, so the distance here, that's the difference, that's our loss in machine learning. We want to make sure that the loss is very minimized. So we want this arrow getting smaller and smaller and smaller. We want a better prediction from our model. That's our goal in machine learning. And if we have a loss of 0, basically that means we have a flawless prediction. So for example, right here at this point, we have the dot is exactly on the line. So our model predicted perfectly what our sales would be for this specific point. So that's an example of perfect loss or flawless loss, right? And the bigger the number, so the bigger the loss, then the more wrong our model was for a given input. And like I said earlier, we want to reduce the loss in machine learning by training our data with varying weights and features and making sure we get the right, basically the right equation for our data points that we have. So congrats, that's what linear regression and loss means in machine learning. So if you guys have any questions on this video, please leave the questions in the comments below. You can also go to my website and leave me a message. So yeah, congrats on finishing this lesson, and let me know if you have any questions.